Hello, my dear friends. This is CH Mahegde. This is the problem on portfolio management, which is very rare in nature. In fact, it has come only once in exams. So, this problem and this concept I have not even solved in my regular live classes, but I've been getting this request from many students on this problem. So, here I'm doing this. So, whatever concept we learn here, whatever steps we learn here, whatever the formula we learn here is only limited to this particular problem. You don't have to think beyond that. If at all it comes in exam, very rare case. If at all it comes in exam, same data points will be there, number will be different. Understand the process, that is steps, and remember the formula. Got the point? Let me read. Ramesh wants to invest in stock market. He has got the following information about the individual securities A, B, C, D, E, F. Market index variance is 10% and risk-free return is 7%. What should be the optimum portfolio assuming no short sales, no shorting concept? Actually, it's called as optimum portfolio using Sharpe index. And in fact, this Sharpe person uses a ratio on trainer. Anyway, I will tell you the concepts and all, so you don't have to remember about those names. We'll try to focus on the process, that is steps and formulas. Problem looks very small. Quite a few lengthy processes there. Many people get confused. So first of all, let me give you the structure of this problem. What we require? We have to give optimum portfolio. What does portfolio will contain? Portfolio will contain certain number of securities in certain weights. So what we have to calculate, portfolio construction comprises of two elements which we have to find out. First element, securities or the shares. I will say securities selection. Right? We have A, B, C, D, E, F. Which security to calculate? That is one point. Then second point, what should be the weight of securities? Once I select the securities, in which proportion, like what is my weight allocation, 60, 40, 10, 30, 30, 30, 10, 60, 40 or 20, 20, 20, 20, 30, whatever. What percentage should be allocated to the individual securities? Now, let me talk about security selection. Which securities are good in his opinion, in the opinion of the Sharpe? What he says, which security to be selected? He says like this. Okay, so he says like this. You first calculate one cutoff point. How to calculate cutoff point? We'll discuss later. So first you calculate cutoff point. So not cutoff point. First you calculate the ratio. Then you calculate the cutoff point. What is ratio? Ratio goes like this. Return of a portfolio, or some people uses RI, return of a security, or RS, whichever you write. I is general term, RI, return of a particular security, minus risk-free rate. So what do you get now? Return of a security minus risk-free rate, you get premium, the extra return for taking risk, then you divide by beta. Beta is the measure of systematic risk. So basically beta of a particular security, so BI, beta of a particular security. So this will tell you the return you got for taking risk. To be specific, for taking specific risk. Okay, so numerator represents the risk premium, return for the risk. Denominator represents the risk, systematic risk to be particular. So in general, it represents the risk premium for 1 unit of beta, risk premium for 1 unit of systematic risk. So for taking systematic risk, how much return extra for that risk I am getting, that is what is this ratio. Now this ratio will be computed for all the securities. This ratio wherever more than cutoff point, and then that should be selected. Okay, what is that point? Let us see. Okay, so what is that cutoff point formula? It is slightly confusing, but I'll try to give. But when we prepare in a tabular format, it will be more easier for you. So please observe the cutoff point C. They give like this. For every security, we have to calculate. It will be this. Okay. So this goes like this. C equals Ri minus Rf divided by sigma E square Ei into beta divided by 1 plus beta square divided by sigma square Ei. Okay. Now this formula looks complicated. Actually, in fact, it is a derived formula. Like, so you remember in duration of bonds, we have written like Macaulay's duration or modified duration is duration by 1 plus YTM. The formula like that. This is also formula like that. To give you an idea briefly, not in detail, just to give an idea what this numerator will do, what this denominator will do. Numerator has got Ri minus Rf, which is premium, into beta. So basically, the premium, whatever we are multiplying by systematic risk and we are dividing by sigma square Ei. That is basically Ei. That is a unsystematic risk, unexplained variance for a particular security. So we are bringing in three elements, my dear friends. One, risk premium. Second, systematic risk. And third, unsystematic risk. Beta is the systematic risk. Sigma square EI, unsystematic risk of a particular security. This is B, to be specific, let's say BI of a particular security, and Ri minus Rf is a risk premium. So three elements are being mixed. Hope you're able to understand. So we are having systematic risk, which is beta, unsystematic risk, which is sigma square Ei. So systematic risk divided by unsystematic risk, beta divided by sigma A square multiplied by risk premium, that is Ri minus Rf. That is numerator divided by 1 plus, we are not taking premium here, we are only focusing on the variances. So beta square by sigma square Ei, systematic risk variance divided by unsystematic risk variance. Sir, why 1 plus? I told you it's a mathematically derived formula, so don't worry. Why in numerator only beta, denominator beta square? Like here we have taken beta, here we have taken beta square. That I will not be able to explain, because again that is out of mathematical derivation calculation. But broadly you got the idea. Numerator has got one part, denominator has got one part. Numerator has got one RF minus RF, that is risk premium. Numerator has got risk premium multiplied by systematic risk divided by unsystematic risk. Denominator 1 plus beta square by sigma E square, systematic variance divided by unsystematic variance. Okay, actually cutoff point, it's not just like this. We will be going in slightly different manner. So, but this is the obvious, this is the two things which are required. So wherever the ratio is more than cutoff point, then weight of the security will then we will be selecting those securities. Then once you select the securities, weight of the security will be selected. Even in cutoff point, this calculation is not so easier. Actually, it is not just this Ri minus Rf. Then we are going to calculate these things. What is numerator? What we got? No. Ri minus Rf into beta by sigma e square. Denominator beta square by sigma e square I. This will be calculated on a cumulative basis for every security. I'll explain the process now for your reference purpose. Okay. Now let me explain weight of securities. So this chart gets over. Weight of the securities is depending on, again, very similar formula. Ratio we calculated, then the cutoff point we calculated. Find out the difference. What is that? You calculate in weight of the securities, you have to calculate Z for an individual security, which is based on first, whatever is in the numerator, select only this part. What is numerator? We got beta I, beta of the security, divided by sigma e square I, same thing. Whatever is the numerator, multiplied by beta, I don't do it. This beta by sigma e square multiplied by Ri minus Rf, I don't do. I'll find out the difference between the ratio minus the cutoff point. The ratio is what? Ri minus Rf divided by beta I minus the cutoff point. C for cutoff point. So the how much excess cutoff point you have. That excess you multiplied by the ratio of systematic variance by unsystematic variance. Like this, you calculate Z for individual securities. Then weight, how do you calculate? Weight in a particular security is calculated by Z of that security divided by total Z. Means what? For one security, two security, three securities, let's say three securities are selected. And for each of these three securities, I calculate Z1, Z2, Z3, total that comes in denominator. Numerator is Z1 of the first security, that will give you the weight. So write down till here, then let me explain the process for cutoff point. Okay. Now, let's go for the cutoff point. Cutoff point C have calculated, but to calculate the numerator denominator, it goes in a certain steps. So for that, let us write down again. Steps to compute cutoff point. Okay, first, step 1 is to calculate the ratio. What ratio? Already told you, right? Ri minus Rf divided by beta of a particular security. You calculate the ratio and rank them. Rank from highest to least. Why should you rank them from highest to least? Why highest is best? Because numerator is risk premium, denominator is beta. Risk premium divided by beta means the risk, premium, the return for every unit of a risk. Denominator will represent 1 when you write the ratio calculation. So for 1 unit of risk, a systematic risk, how much risk premium you got? Higher the number, the better premium you got. Therefore, we are ranking them from highest to least. That is first step. Then second step is you calculate what is in the numerator. What numerator I told you? Ri minus Rf, correct? Divided by sigma e square, ei square into beta. We calculate for each security and then cumulative. What is cumulative? First security, only first security. Then second security will be first plus second. Then third security will be first plus second plus third. Got the point? Cumulative basis. Then step 3, denominator. What is a denominator formula? I told you 1 plus 1 plus anyway will come later. Let me just calculate this beta square. In fact, the formula you can change slightly. This is actually summation. Summation basically means cumulative. That summation symbol you can add in the previous chart. Okay. So this you calculate the beta square divided by sigma square EI and cumulative. So at every step, I calculate this, then next security I keep adding. I calculate, next security I'll add. I'll calculate, next security I'll add. Cumulative. I keep adding one security to the another security. Then I get the cumulative of these things. Then I'll be using the cutoff point like the way what I've calculated. Let us write step 4, cutoff point C will be calculated by what are we calculated in step 2 in the numerator? Oh, this is step 2 multiplied by cutoff point. I not explain one thing actually. In cutoff point, this formula what you calculated, you have to multiply it by market variance, sigma m square. This also you have to compute by market variance for that sigma part. Market variance you can multiply. So what will be the cutoff point? This step will give you easier one. It will be 1 plus step 2 what we calculated. Then you multiply it by market variance divided by 1 plus, no, just step 2. Denominator will be 1 plus step 3 cumulative multiplied by market variance sigma m square. Lot of formulas are there. That's why I told you you have to keep this problem at the last. It's a rare problem. If at all comes in exam, same structure of the data comes, only the numbers will be different. But that too, it comes only once in last 20 years. I really don't expect this. Even for the people who learn portfolio management like MBA people, this is not very popular theory. But anyway, many people have requested, so I'm solving this. So write down till here. Okay. So I hope you got the point. Now let's go for the calculations. After the set cutoff point, after cutoff point, wherever cutoff point is crossing the ratio, that ratio should be here. Securities you select. Based on the security you selected, you compute the weights. Till then, you have already calculated. So let's go further. One small point of shortcut you can say in this whole circus. One small point of helpful tool mathematically. You please observe. Here we got Ri minus Rf divided by beta in step 1, and in step 3 I've got beta square by sigma e square I. If I multiply these two, what will happen mathematically? Just observe Ri minus Rf divided by beta multiplied by beta square divided by sigma e square. What will happen? This beta square by beta. So beta gets cancelled, this square gets cancelled. So what I remain is Ri minus Rf into beta by sigma e square. That's what I get. Step 2. Beautiful, isn't it? Step 1 you take, and step 3 you take. Those two you multiply. That's how you get simply step 2. Step 1 into step 3, you get step 2 automatically. This will say sometimes. So let's try to calculate. Okay, so first step is to rank them. Let us solve it. So first step, as we have written, step 1 ranking, the ratio calculation and ranking. Okay, so they have again the made question, expected return beta sigma e square. So what is the ratio calculation? Securities, let's calculate. Then the ratio, the rank. Okay, securities A B C D F, A B C D E F. Okay, the ratio calculation, you know the Ri formula. I'll just write once more here. Ri minus Rf, basically risk premium, divided by beta. So for the first one, expected return is 15 minus risk-free return is 7 divided by beta 1.5. So 15 minus 7 by 1.5, 5.33. Similarly, next, I'll write slightly faster. 12, 10, 9, 8, 14. 12, 10, 9, 8, 14. 12, 10, 9, 8, 14. So minus 7, minus 7, minus 7, minus 7, minus 7. These are all the numerators divided by beta. 1.5 is done. 2, 2.5, 1, 1.2 and 1.5. So that will give me the numbers 12 minus 7 by 2, 2.5, 10 minus 7 divided by 2.5, 1.2, 9 minus 7 divided by 1 is 2, 8 minus 7 divided by 1.2, 0.83, 14 minus 7 divided by 1.5, 4.666, 4.67. See, these are the ratios you got. 5.33, 2.5, 1.2, 0.83, 4.67, 1.22, 4.83, 4.67. Okay, very good. Okay, now let's rank them. Ranking is very simple. Do from highest to least. So highest one is 5.33, security A first rank. Next highest 4.67, that is second rank. Next highest 2.5, third rank. Next highest 2, fourth rank. Next highest C, 5th rank, next to highest, E, 6th rank. So A, B, C, D, E, F. 6. A, B, C, D, E, F. Yeah, 6 ranks. So 1, 3, 5, 4, 6, 2. That is the ranks. Okay. Step 1 is done. Now step 2 is calculating this cumulative values. But step 2, step 3, I don't want to do it in separate table. Let me do it in a columnar format. And that too, I told you, it's better we calculate step 3 first, because this number, if I multiply it by step 1, I get step 2 automatically. So let me repeat that. So calculation of cutoff points. I hope you have done till here. I'll just wait for a couple of seconds. If you're still writing, you can take a picture. Okay. Now, let's do calculation of cutoff points. Calculation of cutoff points. So what I'm going to do, one column I'll have for securities. One column I'll have for securities. One column I'll have for the step 1 calculation. We already calculated ratio. Step 1. What is step 1 calculation? Ri minus Rf divided by beta. We already calculated step 1. So I'm going to make use of that. Then for me to go to step 2, I'll first calculate step 3, because I told you mathematically it's easy for me to calculate. What is step 3? Step 3 is calculated by uh, beta square by sigma ei square. Beta square by sigma ei square. Then I'm going to calculate step 2. Formula looks difficult. This is like Ri minus Rf divided by beta divided by sigma e square multiplied by beta, right? Ri minus Rf divided by sigma e square into beta. But we are not going to follow that. We are going to follow simple process, that is step 1 multiplied by step 3. I get this automatically. Then I will be doing cumulative. What is that? I'll be doing cumulative step 2. I need some space in the column, so write down carefully. Cumulative step 2, then cumulative step 3, cumulative, you understand, one after the another. Then the cutoff point. How do you calculate the cutoff point? I'll write the formula once more. 1 plus step 2 into sigma m square divided by, not 1 plus, just step 2 into sigma m square divided by 1 plus step 3 into sigma m square. Step 3 into sigma m square, market variance, and that too, this will be on a cumulative basis. Okay, now when you're writing securities, please don't write in A, B, C, D. Write in the order. What is that order? First was A, then second rank was F, third rank was B. Follow that order. So you get first rank was A with a ratio of 5.33. Second was F with a ratio of 4.67. Then third rank was B with a ratio of 2.5. Then fourth was D with a ratio of 2. Then fifth rank is C with a ratio of 1.2. and sixth is E. A, B, C, D, E, F. C, D, E, F, R. 6. So E last one, which is ratio 0.8. So AF, BD, AF, BD, C. Yes. Okay. Step 1 we calculated. Step 2, beta square by sigma E square. What is beta square? You can check the calculations or look at the table. Look at the question. Looking at the question will do real fast. Beta, last but one column. Sigma is square, last column is already given. So first beta, you need square. So do it carefully. Don't take those numbers. Corresponding number you have to take. So beta square means 1.5 square for A. Then for 1.5 square divided by 40. Let me first write down, then I'll calculate. Then for F, beta is 1.5 again, 1.5 square divided by 30. Then for B, it is 2 square, beta square. From the question, hope you are able to identify. Divided by sigma is square, last column, that is 20. Then for D, beta is 1, so 1 square divided by 10. For C, it is 2.5, 2.5 square divided by 30. For E, 1.2, so 1.2 square divided by 20. Let's see if I get these numbers. Okay, so 1.5 square divided by 40, 0.056. 0.056. You can take 3 decimals, 4 decimals, everything is fine. I'll take 3 decimals. Institute also has taken 3 decimals. 0.056, then 1.5 square by 30, 0.075. 2 square by 20, 0.2. 1 square by 10, 0.1. 2.5 square by 30, 0.208. 1.2 square by 20, 0.070. 0.702. So 0.056, 0.075, 0.2, 0.1, 0.208, 0.70, 0.07. 0.07. Oh, sorry, 0.07. 0.07. Okay. Now step 2 I have to calculate, which is step 1 into step 3. The previous two column I have to multiply simply. So let me multiply. Or before that, I'll just do cumulative part. So that difficult one I'll do it first. So I'll do cumulative part. 0.056, that is as it is. Cumulative for step 2. Oh, I have to come to step 2. Cumulative step 3. So I'm doing this column actually, because what I've calculated is step 3. Okay, step 3. And the cumulative step 3 I'm doing. Please observe, cumulative step 3 I'm doing. That is 0.056 as it is. 0.056 plus 0.075. Hope you know the meaning of cumulative. 0.131 plus 0.2. 0.331 plus 0.1. 0.431 plus 0.208. 0.639 plus 0.072. 0.711. Cumulative, adding one after the another. 0.056, 0.131, 0.331, 0.431, 0.639, 0.71. Clear? Now we'll come to step 3, step 2, which is step 2 is calculation of the multiplication of previous two columns. So I'll use different color so we can understand. So step 1 multiplied by step 3. Big formula will take time. A simple method I told you. So multiply 5.33 into 0.056. 0.29848. I'll round it off. 0.298. Okay, I'll take 3 decimals. 0.298. Then 4.67 into 0.075, 0.35. 2.5 into 0.2, 0.5. 2 into 0.1, 0.2, 1.2 into 208, 0.208, yeah. 0.2496, I think I'll round it off, I get 0.25. Then 0.83 into 0.072, 0.0596, I'll may say 0.06 when I round it off. 0.06. Cumulative. So 0.298 is the first number. Add this 0.35 because cumulative step 2 I'm doing. So 0.298 is done plus 0.35. 0.648. Plus 0.5, 1.148. Plus 0.2, 1.348. Plus 0.25, that is 1.598. Plus 0.06, 1.658. Okay. Last step, step C. I don't have space to write down. I'll just show you for the security A. See how to calculate for A, like that CA, CB, CF, everything you should calculate. Step 2, that is, we have already cumulative column. This step 2 column, which is 0.298, 0.298 multiplied by market variance, which is 10 square. No, 10. 10 is market variance, not 10 square. The given market variance is 10. Divided by, because variance itself is square only, divided by 1 plus step 3. Step 3 calculation is this 0.056 multiplied by 10. You need not show calculation like this. You can show if you want. I'll show you for 2 securities. If you want, you can show for more. So I'll just do for C A is done. CF also I'll show. So 0.648, 0.648 multiplied by 10 divided by this 1 plus, 0.64 into 10 divided by 1 plus 0.131 into 10. Like that you can calculate for each security. So how to calculate in calculator? Use m plus function. Clearly you will be able to solve it. Let me show it to you. So let me show the first one. Always calculate the denominator first, then keep that in memory. Easy to solve. So I'll do 0.056. I'm doing for A into 10. You get 0.56 plus 1. You get 1.56 m plus. Keep that in memory. Then you do numerator. 0.298 into 10. You got 2.98. Then you do divided by MRC equals. You get 1.91 something. So 0.298 into 10 divided by MRC equals. Okay, 1.91 you get. 1.91. Okay. Instead has taken slightly different decimal. They get 1.923, but that's okay. 1.91 you get. That's okay. 1.91. In fact, what Institute has done, they have taken all these, because these are all 2 decimals, so they have taken 0.3, they have rounded it off. That's okay. 0.33 into 0.056, 0.29848. 0.298. See, if I round it off, 0.29, 0.3 I get, right? Okay, let me also do what institute has done. So I'll make this round off to institute answer matching. So this I'll make it as 0.30. I'm just rounding it off. This I'll make it as 0.3. So this basically will get rounded off. It will get 0.65. So you get 1.15. You get 3.5. 1.60, I think. 0.3, 0.65, 1.15, 1.35, 1.60 you get, I think. Okay, so 1.60 and here you get 1.66. Okay, so we can let me use what institute has done. Same process also you can do. So what will be calculation? Okay, this one will remain same. So this instead of 0.298, I'll make it as 0.30. Instead of 0.648, I'll take it as 0.5. So in this case, if I do so calculation again, when you calculate m plus again, please calculate the memory first. So clear the calculator memory. Sometime MC will be there or clear button will be there. So calculate denominator first, 0.056 into 10. You get 0.56 plus 1. You get 1.56. Keep it in the memory by pressing M plus. Then you numerator 0.3 into 10 divided by MRC equals. You get 1.923. Okay. Similarly, calculate for the second one. Second one means what I've done here. Again, first calculate using M plus you can do, but clear the calculator memory first. Clear the calculator memory first by pressing MRC or clear button or on button, whatever it is, clear the calculator memory. Again, denominator first now, 0.131 into 10 plus 1 equal to M plus, then 0.65 into 10, you get 6.5 divided by MRC equals. You get 2.814, 2.814. Okay, I'll do for next also CB. Numerator should be step 2. Step 2 is what we have in the immediate previous column. Here we have to use only this cumulative columns. That is 1.15 into 10 divided by 1 plus 0.331 into 10. That is for the third, that is for CB. So clear calculator memory again, then start fresh. Calculate denominator first, 0.331 into 10 plus 1 M plus 1.15 into 10 divided by MRC equals 1.10149. Point 331 into 10 plus 1 M plus 1.15 into 10 divided by MRC equals 2.668 something. Okay, 2.668. 2.668. Okay. Next, I'll just calculate for D, CD. Step 2, which is 0.2 into 10 divided by 1 plus 1.35 into 10. Step 3 into 10. Use only the cumulative columns. So clear the calculator memory. 0.2, no, calculate denominator first. So 1.35 into 10 plus 1. Keep it in memory. 0.2 into 10 divided by MRC equals 0.137. Something wrong. What happened? Calculate once more. 1.35 into 10 plus 1 M plus 0.2 into 10 divided by MRC equals, oh, something is wrong, 0.331 into 10. Oh, sorry, not 1.35. It's 0.331. Oh, sorry, 0.331. That's why that's mistake. Okay, 0.331. 0.331. Okay, now let's calculate. Clear calculator memory, start fresh. 0.331 into 10 equals plus 1. Keep it in memory. 0.2 into 10 divided by MRC equals, okay. Now you get the number. Not 0.331, sorry, 0.431. 0.331 is already done. 0.431. 0.431. Why is this so many mistake I'm doing? 0.431 into 10 plus 1 m plus 0.2 into 10 divided by MRC equals not 0.2, 1.35. Why? Come on, why so many mistake? Sorry, my dear friends. 1.35 into 10 divided by MRC equals 2.542. 2.542. You know how I'm able to understand the mistake I'm doing? This number, once it starts decreasing, it will always decrease. 2.814, 2.668, 2.542, it's decreasing order. So next two also will be down only. But anyway, I will do it. Next, I just take the first two part out. Only two things are pending. So C and for E, I have to calculate. So cutoff point for C, step 2, that is 1.6 into 10 divided by 1 plus 0.639 into 10. So clear calculator memory. For calculate denominator first, 0.639 into 10 plus 1 m plus 1.6 into 10 divided by MRC equals 2.165. Okay, this time we are doing right. Then last part CE, that is step 2, 1.66 into 10 by 1 plus step 3, 0.711 into 10. Calculator, clear the calculator memory, calculate denominator first, 0.711 into 10 plus 1 equal to m plus 1.66 into 10 divided by MRC equals 2.0468, 2.047. Okay. Now the interesting point, I think I did not tell you the earlierly, I want to tell you now, which is the cutoff point. Cutoff point means wherever C starts reducing. Where is C start reducing? You see 1.923 became 2.814, it increased. So where it reduced, this is the point, right? Because 2.668, next is less. It keeps on reducing. Once it starts going down, it starts going down. So this is the highest. So you select the highest cutoff point. Highest cutoff point. And which securities which will cross this 2.814? Obviously security A and F. Highest cutoff point A and F you can say. So because 5.33 is more than 2.814, 4.67 is more than 2.814. So cutoff point is the highest in the C column. And which security crosses that? That is A security crosses, F security crosses. So security selection is A and F. Only A and F. These two securities, the ratio will cross the cutoff point. Cutoff point is 2.814. The highest in the last column becomes cutoff point. Wherever the ratio more than that, those securities are selected. Remember, going back to the steps, security selection, the ratio should be more than cutoff point. Cutoff point is 2.814, the highest, and which ratio crosses 5.33 is more than 2.814, 4.67 is more than 4.67 is more than 2.814. Only two securities are selected. After calculation of cutoff point, what next? We have to calculate weights. So please write down, in case you're not written down. Okay, let's go for the weights. Let's revise what was the weights calculation. Is the cutoff, whatever the ratio minus the cutoff point, then basically multiplied by our step 3. Beta by sigma E square, that only we are going to calculate. Anyway, so let me write it separately. Calculation of weights. So securities. Then we'll have to calculate the Z value. Then we'll calculate the weights. Z value is given by, Z value for a security is given by, we'll calculate the surplus. That's the formula, right? Yeah. So Ri minus Rf divided by beta. This is the ratio we get minus the cutoff point. That is the surplus we get. This surplus multiplied by beta square by sigma Ei square. Beta square or beta? Beta only, okay, not beta square. In fact, beta by sigma Ei square, we have already calculated here. Beta by sigma Ei square. Correct, beta square, but we don't require beta square actually. Okay, we require only beta. Okay, let me use this number now for security, only two securities, for security A and for security F. So let's calculate for ZA and then let's calculate for ZB, ZF. Sorry. Okay, so beta of security A is 1.5 given in the problem. Sigma Ei square given the problem, next column only 40 multiplied by the ratio. The ratio is 5.33 minus the cutoff point. The cutoff point we calculate 2.814. 2.814. Let me calculate for F also. Beta, go back to the problem. In the problem for F, beta is 1.5. So for this also 1.5. Divided by sigma E square, next column only 30. Its ratio we calculated 4.67 minus 2.814. Let's calculate Z value. So 5.33 minus 2.814 into 1.5 divided by 40. 0.09435 something. Oh, into we have to do. Now 0.09435. Okay. So 0.09435. And similarly here, 4.67 minus 2.814 into 1.5 by 30. 0.0928, right? Yeah, 0.0928. To calculate the weight, do the total of these Z values first, cumulative Z values. So 0.0928 plus 0.09435. 0.09435. 0.18715. 0.18715. Okay. Calculate the weights. 0.09435 divided by the total 0.18715. 0.0928 divided by 0.18715. 0.09435 by 0.18715. 0.5504. 5041. 0.5041 means 50.41% multiplying by 100. And 0.0928 divided by 0.18715. Remaining you get basically 0.4959. 0.4959 means 49.59%. So ultimately, after this optimum portfolio theory given by Sharpe, the security selected are security A, security F, and in security A you have to invest 50.41% of whatever amount you have. In F, you have to invest 49.59% whatever the amount you have. So that's it, my dear friends. Hope you are able to understand. Don't attach too much of sentimental feelings about this problem. It's rarely asked. I told you it's only one problem, even the institute material, and the examination asked only once. So don't take it too seriously. But for those who want aiming 80 plus 90 plus, you can try out this problem. Okay, so that's it with respect to the problem on optimum portfolio.